pleasure to introduce our next esteemed guest, who really is at the forefront of helping companies apply AI to their businesses. Newly found Managing Director of Deloitte Digital. Please give a warm welcome to Susanna Fager.
So, okay. So very hard to speak after Faye. It was an interesting talk. But I will go for a little bit another topic. And that's a topic that popped up in my environment summer last year. And it has to do that already the bigger companies need to report the ESG. And so the team I had at that time, I was wondering what can we do with our AI solutions? And I have one motivating slide for that, and that shows, I heard it already a little bit today in different presentations, because right now we already see, we all talking about aviation, we're talking about cars, but you already see on the slide, and it was on MIT a couple of weeks ago, that we already have more carbon footprint concerning digital solutions than with aviation right now. And this is the current status. So if we look into the future, and if we look only in 2022, we already see that we have more emissions with digital product than with cars and with aviation. And this is not the first step, so it's really going exponential. We had already today quantum computing, so it takes energy. If we think about IoT, if we think about everything we have in all our lives here. And so that's one of the motivations to take a closer look. And what we see right now is that everyone is talking about sustainability, everyone is talking about applications. They're looking at, for example, in my former job, to predict, for example, optimized flight routes, predict how many menus I need for the flights, or predict whatever. Or looking at energy, I just went over to really optimizing energy. But there are only a few things to look at. What do we produce from AI and from digital solution concerning the digital footprint? And I have here a nice graphic, because if you look at that, it's not that you do it once, you do it all the time, and you're producing permanent emissions footprint with your AI solutions. When you think about it, and I mentioned I started in summer, so what you see, and you see is in several studies, if you look at GDP3 and look at the energy they already spent for that one, and I was really shocked when I saw it's really 63 homes energy. So everything you do at home, heating, like surfing, virtual conferences, so it's an average of everything you have in your home for a whole year, so 63 homes. Or you can charge your phones, 61 million phones with the things, the energy only GDP3 took for training. This is not the usage, it's only the training. And if you look at the Bloom model, it's a little bit less there, so only around 3 homes energy, and about 3 million smartphones. And I have to show that a little bit because everyone is talking about airplanes. So airplanes is this little mark here on the lower side. This is if you are traveling from New York to San Francisco, and that's the emission there. So you see here the effect. And that was the motivation to look a little bit closer to that. So everyone, if we think about like AI training and so on, everyone is thinking about model development. Everyone is talking about what kind of hardware we are using, what kind of RAM we are using. But if you do an AI project, you have more. And that's a little bit like here on the slide, the iceberg, that it's a little bit lower, where we have everything about what kind of devices the employees are using, like laptops, phones, then everything about data storing, depending on the model, what you're doing. You're storing a lot of data. You might travel, it depends a little bit, so you have the travel time, and you have everything about fixes, monitoring, and so on. So what we thought is we take a closer look at the life cycle, and we make it in the first step relatively simple. So as life cycle, as basic, we took the life cycle of Amazon. It doesn't matter so much what kind of life cycle, so they are similar, you all know that. And we thought we taking one life cycle, like preparing the business goals, doing the formulation of the machine learning problem, then looking for all the data, doing the data quality, doing the model development, then the deployment and monitoring. You all know that. In the first step, we saw, okay, we are looking at the first phase emission. That means only the emission I directly need for that project. So we are not looking for ESG, you look for 2 and 3. So how much emissions do you need to produce your PC, or how much emissions you need to produce a GPU? So we didn't do that. We just took like a very simple one row there. And we didn't look at retraining and everything like that, because it would make it complicated. And what we took, and that's a little bit more complicated slide, so we took a little example from our project. So we did before. It's not a very complex one, a very easy one. And you see it here. So we thought, okay, we have 2 employees. We have an image processing problem there. We have a data set of 50 gigabytes. And we have 2 employees with 50-watt laptops there. And then we said, okay, we have a GPU with to train everything, and it's about 350 watt. So that is our basic. So first we went to the usage, and you are all in AI, so you nearly know how much time it takes. And we put it there, the time the employee takes, so it's basically laptop time. Then we have the data storage, and we have the GPU storage. And we did the estimation of the time, or the measurement of the time for each of these phases. And no surprise, you have first only like the employee's laptop, then you have in the data processing, you have the data storage. We start for the first things using the laptop, and then we have only half of the data. And the next phase, we have everything, the laptop of the employee, we have the data storing, and we have the GPU there. During the deployment, only less. And for the monitoring, that's very special, because you have to see that it's only the monitoring for 1 month, so it's a little bit different. So we took that time. We had everything from the energy consumptions of the devices. We had what we need to estimate what kind of energy the data storing needs. And from that, we calculated the energy consumption we needed for every phase of such a project. And then we took the public map of Germany, how the electricity map, and calculated how much carbon emission we produced in every phase of that little project. And the result you see on the right-hand side over there, it's not so surprising. So mostly you have it during the data processing, and the huge one is during the data modeling. Just to briefly say it, so during the data processing for this little project, 109 phones you can charge with that. For the development, you can drive 930,000 kilometers with an average car. And the last one, it's tiny again, but you have to remember it's just for a month, so it's recurring every month. So that's just some KPIs and a small summary to make it very pragmatic. If I'm looking at the different phases, we started in the first phases, you have only the PC. In the example, we hadn't any travel there. You have the devices. Then in the next two phases, you have basically the data storage and the computation. Additionally, you have PC and travel and devices. And in the deployment and monitoring phase, you have all the other things, additionally the usage of the application. And now the question is how to measure that. And what we didn't find, I can tell you, we didn't find a tool that is really measuring everything, so that you just put the button and get all the energy your AI application is producing, but we found some solutions. So the first one I have is our own internal travel carbon footprint, what we already have from our customer relation management system, that we are taking the travel of every consultant and calculating the footprint we are producing with this kind of project. And this is just an example, like with a car from Frankfurt to Munich and from Nuremberg to Munich, and the other way around, by car and then by train. I found it quite interesting. If you like to test a little bit, you probably know the Deutsche Bahn carbon footprint calculator. So you can put in the distance you are traveling and you are getting the results. You probably know that there are different APIs you can use to really calculate the footprint of your travel. The other one I have, if you're in the cloud and producing all the training in the cloud, you already have from all the hyperscalers dashboards about what your company is using, and you can look at it. They are very similar, so there are different measures. They are different dashboards, but you already can see what you are producing there. Then if you have already a project or you are planning a project, what we found from a research paper is a little tiny estimator that's calculating only the footprint of the machine learning part. It's relatively easy, like my example. So what you have to put in, you have to put in the hardware type, then you put in, like I did it before, the usage hours, then you say what kind of cloud provider I'm using and the region where you compute the model. And just mentioning that, I have it later on, it really depends on the region and the time of the year, how much emissions you are producing with your model training or usage of the model. The advantages tool we found is called CodeCarbon. It's open source, and what you can do, you can integrate it into your Jupyter code into your Python code, and then it's calculating everything on your laptop and everything you are doing during the training. And it provides you a dashboard where you can check how much energy, how much emissions you're producing with your application. So data storage is not integrated in that tool, and the travel is not integrated into, and not the monitoring and the usage of the application. But it gives you, in the first step, a quite good measure, easy to use, to have first insights here. And the last slide I have here is more a little bit about what do we do with all the KPIs, because it's always nice to measure things. So you have, if you measure that, the baseline, but nevertheless, there are already a lot of studies, papers, advices, what we should do if you're developing AI solutions. And we put here the 4 M's of Google on that slide, but it's basically similar in other studies. First one is what kind of model, what kind of solutions you are using. Depending on how precise it needs to be, you always should check what you really need to solve that business problem, and you can really save 3 to 10% of the energy you're using. Then the type of machine you are using for the overall training and everything. So it depends really on the problem, it's about 2 to 5%. Then the type of cloud, if you do it on-premise, it's not the recommendation, but to do it in the cloud, and then what country you are using, and that's the graphic on the left-hand side here, because it depends a little bit on the time of the year, which is the optimal solutions to choose here. And if you take, for example, the dark green line here, that the US central line, it really drops down in May, so you have much less carbon emission in May, but it's going up again in August and November. So you always have to be a little bit aware at what time you are doing the training and what kind of region you should use to train your model. And the last is a little bit guidelines from at this time about what we found with Amazon. It gives you direct guidelines, recommendation in the Amazon environment, and it focused here only on Amazon, but it's very detailed. And that's the next step, but to measure it, it's for me always the first step, because if you then use these guidelines, then you can see what you're safe with all your improvements. And that's the end of my presentation. Thank you.
Thank you very much, Susan. So we have some time, if you don't mind, for me to ask a few questions. And please, I'll open the floor as well if you have any of your own. So I was personally quite shocked, actually, by some of that data. Hadn't quite appreciated by how much we do have a carbon footprint as a result. My question is around who owns that problem, or who do you believe should own that problem within an organization? And if I think about my data scientists that work for me, if I was to curb what they would like to do and what they could use, I would get a very big backlash from them, and we're stopping innovation as a result. What would your advice be, or where do you see that evolving going forward now that we even have KPIs?
Yeah, it's a little bit like the ethical topic.
Yeah.
Because you need some education, and it always has to be. You have your business goals, and then you have to see how much can I do and where I have to do that. But what we see, and we already have it for big companies, that you, in your advisory and reporting, yearly reporting, you already have the ESG there. And the first questions is coming, and I had it from some clients, that the advisors already asked how much are they producing which in AI. And it's not that you are not doing like fancy things, but like I said in the last one, you always at least should be aware that you can choose where you train your model to reduce it. It will always cost energy.
Yeah, fantastic. Any other questions from anyone on the floor? Please, a microphone at the front. Thank you.
Hi.
Hi.
I was wondering why, do we know why the CO2 grams emitted are lower or higher in some months for some countries and not for others?
Yeah, it's because in summer you have, for example, solar panels. Then it goes down because it's greener, and then in winter it's go up. So the curves that are going up and down the most, the highest waves, are normally like countries who are more in the north, and not in the not in the tropical areas. That's the reason why.
So you think we should train more models during the summer in the different countries we're in?
No. For example, if you you can train it in summer, or if you do it, for example, in Germany in winter, you can say, and you already can do that with your cloud provider, say, I want to train my model in, I don't know, South Africa or Namibia or whatever, where you still have, and that's the reason to take a closer look at the open app, the electricity map, where we really can see how much green energy every country is producing right now.
Thank you.
Thank you. We have a second question here, the gentleman in the black jersey. Oh, sorry, I'll come back to you in a moment.
Thank you very much for this, for the insights on the carbon emission. I want to ask you a question about like how to actually capture the full life cycle of models, because it's like not as simple as like, oh, I have a model I'm running in production, I have to inference cost, but I have also like the amortization cost of like training these models, and especially with those large language models, it's becoming significantly more complicated because it's a huge invest and a carbon invest in training a big language model. But then the inference costs are also not quite small, but the use cases that you can cover are huge, and you save a lot of carbon by using a large language model instead of training like small bespoke models over and over and over again. Like, how do we actually start capturing this kind of like non-optimal point if we just like optimize every single step of the curve? It's actually suboptimal as compared to like the full.
That's the reason why we wanted to see the different phases, and I agree with you. If I have a very high, and that's the reason why I pointed out the monitoring phase, because we always have to see that we do it again and again and producing much more. So you always have to look at it from the whole life cycle and during the operation. And I agree with you, this is very pragmatic, is a first view, because if I'm going in every detail, it's very, very complicated. So what we did here is just to give a first glimpse where you can do something and what you have to consider. You might have to go really into more details, but I'm not so sure if the effort we are then taking really gives such better results. So something like that is relatively easy, and you get a first glimpse, and it costs you not so much performance, energy, working hours.
Thank you, Susan. So it's a start. So I'm going to go back to the lovely lady with the blonde hair, and then I'll move over to you, sir.
You talked about that, and I was also really shocked about that one graph you showed around the U.S. households. And I think there's, of course, a stereotype that you think, okay, everybody needs a lot of energy there. My question is, do you foresee, and we had, I think, a energy crisis, right, a couple of months ago, I think everybody remembers, at least in Germany, that there will be also maybe political intervention in terms of how much energy you could leverage for that? And is there also a need for prediction? So I understand that now it's a lot of, this is what happened, right, when you flew from New York to San Francisco, but shouldn't we not actually leverage that even more and say, this is what we actually calculate, and we should not go over that if we have those goals and not just pay for it, right? To, I mean, if I book a flight to San Francisco and I just click on the beautiful Lufthansa button, that makes me feel great, but it actually doesn't solve the problem, right?
Yeah, it doesn't solve the problem. So for companies, right now what we already have is that enterprise companies have to really report the ESG, and depending on that, you already get credits for investments. You have that, and it's quite obvious that we will get that in Europe for all companies. So for the company side, you are forced to do that. For your private, I'm not so sure if the governance will really go into such restrictions. It's more, and that's the reason why I showed the Deutsche Bahn calculator. It's a little bit, I believe it's education and awareness. And what we're seeing right now is a lot of awareness, especially for the younger person, that they are more aware and not taking so much flights, but even so, they are surfing a lot. I believe it's quite difficult to give, from a governance side, really a regulation there.
Thank you. And so, gentlemen, the final question.
Thomas.
No, but I'm sensing a little bit of a, I don't know if contradiction is the right word, but I've seen these numbers before. If you actually throw in the calculation of CO2 when it comes to serious blockchain activities, it's much, much worse than this. But my question is, on one end, you have the whole world chasing sustainability and global, CO2 reductions and whatever the goals are for 2020, 35 and whatever. So here comes AI. So who is losing and who is winning? On one end, we have, worldwide goals for CO2 emission reduction. Since ChatGPT, AI is really kicking into gear, plus blockchain will be just around the corner. One is a give, one is a take. I mean, I don't see a solution here where everybody by the end of the day is happy. Either AI needs to slow down, which certainly is not going to happen, but then the people who are after the sustainability and the green and all of that stuff, it's like, I am not sure it will add up. Yeah. What's your opinion?
Yeah, I agree. It's very difficult because we see it in history that people are using things without thinking about sustainability and stuff like that. Nevertheless, I believe if you put too much burden on it, then it's quite difficult. But to have at least some spotlights on it, I believe we should do that. Especially when you, on the first slide, it's not from me, it's from colleagues from Switzerland. And when I saw it myself, I was really impressed, and that impressed a lot of my colleagues. And it's not that you can do nothing, but raise the awareness a little bit. Like we raised the awareness in the companies for traveling by train instead of traveling by airplane for business trips. So my wish was during the last days, don't have music in hotels on the floor, and don't have in the hotels all the lights on and stuff like this. Is just little signs. It's very difficult to solve everything, but I believe we have to take a little bit more effort to go really into green energy.
And I suppose the reality is that it's an ethical question that will be maybe a generational change, if anything. But thank you for your question, and thank you for a wonderful presentation.
Danke.